Good day, guys. Welcome to GJS Academy, and our topic for today is on integration by part. All right, so this is quite different from integration using use substitution. The difference there is that for integration using use substitution, one of the power has to be greater than one. But the moment whereby you come across a question in which you cannot, or maybe the powers there, for example, you have 1 to be the power of x to the power of 2, and maybe you have 1 to be x to the power of, let us say, 4 plus 1 to the power of 3. Then you know that solving stuff like this, integration by parts is not going to be able to do anything here. So in stuff like, you'll be able to use what? Integration by what? Part for a question like that. Now, without wasting much of our time, how do you apply integration by parts? So the law states that when you have the integration of u dv, it is equals to what? Let me bring it down here. U times v minus integration of what? V, then what? Du. Now, looking at this formula here, what are the items that you need to know? You need to know your u, you need to know your v, you need to know your what? Du, and you need to know your what? Dv. Let me write this very well. So these are the 4 items that you need for you to be able to apply your integration by parts. Now, starting with the first question here. All right, let's get solution. So we're going to integrate what? X to the power of e to the power of x dx. Now, let's make this our what? U, and let's make this our what? V. Are you with me? So this is our u, this is our wrong. This is our u, this is our what? The whole of this here is our what? Dv. So this our u is equals to what? X. Let's put our v here. Our v is equals to what? Unknown. Our du is what? 1. Our dv is equals to what? E to the power of x. Now, for us to get our v, we need to find what? No, this is what? The x. We need to find the derivative, the antiderivative of this. And to get our antiderivative of this, we already did that in our previous video. That will still give us what? E to the power of what? X. Now, let's now start our application. So, this equation here, this is it here. So, we were told that it is equal to what? U. What's our u? X times what? V. What's our v? E to the power of x minus integration of our v. What's our v? It's still what? E to the power of x times what? Times du. This is our du. Times 1, then you put our dx. Note, our dx is here. So anything times 1 will still give us 1. So we can safely rewrite this as what? X e to the power of x minus, if you have to find the integration of this, it will still give us what? E to the power of x. Then we add our plus c. So this is our answer, unless you choose to factorize yourself. But in this context, I don't feel that is necessary. But let me just write it for you, for those that wants to get it. So this, you can leave your final answer like this. Look, question 1 done and dusted. Now let's move to question 2. Integration of what? X sine x dx. Now, like I said, whenever you want to pick your u and your dv, always aim at something that you can easily integrate or differentiate. So it is not a must you make this your u and you make the whole of this your dv. You can do it in any other easier way possible. But for this contest, this is quite easy to integrate. Both are easy to integrate. So you can just pick anyone. Let's still use our standard format. This is our u is equals to what? X. Our dv is equals to what? Sine x. So our du is equals to what? 1 dx. Then our v. If you should find the antiderivative of sine x, it will give us what? Minus cosine x or minus cos x. So we can now copy and paste. So our answer here will be what? U times v. That is u times v. Minus times plus is give us what? Minus x cos x minus integration of what? V. But now we are having minus here. Cos x times what? Du. And du is equal to what? 1 dx. Are you getting me? So this is equal to what? Minus x cos x minus times minus will be what? Plus integration of just cos x dx. So now we know that integration of or antiderivative of cos x is what? Positive sin x. So we can now write this as what? Minus x cos x plus sin x plus what? C. This is our final answer for question 2. This is that about question 1 and question 2. So now let's move to when we have what? Lane. All right. Now, looking at this question, it is looking as if there is not dv here or there's no u. Okay, we can easily say this is our u, but where is our dv? So now let's do it this way. Then, the coefficient here is what? 1. You can say ln x times 1. So this can represent what? dv. And this can represent your what? Your u. So we can say this is our u. And this is our v. Now, why am I making use of this as u? Because it is easy for us to find the derivative of what? Ln x. And it is more easier for us to find the antiderivative of what? 1. Therefore, this is our what? dv, right? This part here is equals to dv. Why this part is equals to u? So our u is equals to what? Ln x. And our du is equals to what? If I find the derivative of our ln x based on what I've been doing is what? 1 over x. If you do not understand how we got that, go and watch our video on differentiation. You will get that. So this is 1 over x. Alright. So the derivative of ln x is equals to what? 1 over x. Then our dv is equals to what? 1 dx. So if you find the derivative of this, it will give us what? X. All this stuff is something we have done in our previous video. So it's something I assume, or yes, it's something I assume you know already. So if you don't, go and watch our previous video so you have a better understanding on it. Now, we can now say that our integration of u dv, which is this, is equal to what? Our u, which is ln x. Ln x times x. So I cannot bring my x here. Ln x times x is like saying u times v or v times c, but they are both the same thing. Minus integration of what? V. And v is x times what? Du. That is what? 1. Remember our dx is here. That will be what? 1 over x dx. Can you see how interesting this particular part is? Can you see our x will just cancel each other. So we can now see that our x ln x minus integration of 1 dx. Therefore our final answer is x ln x minus what? Integration of 1 is what? Just x plus c. So you can also choose to write as what? X in bracket ln x minus 1 plus c. That is our final answer for question 3. Now the next one is what? It's number 4. Antiderivative of what? X ln x dx. Now, so this is where I will now be taking a different measures. So instead of me to make this our u and make this our what dv, I'll be switching it over y. Like I said now, like I said earlier, make the value of your u be something that you can easily what differentiate, and make the value of your dv something that you can what easily find the antiderivative of it. If I have to make this u, let's for an assumption now, if I have to make this u and I make this dv, me having to find the antiderivative of this, although we have done it here, having to find the antiderivative of what ln x is going to take me a whole lot of time. So instead of doing that, after all, I can just rewrite this as what ln x times what our x dx, in order to save us some stress. After all, we arrive at the same answer. So this is our what u and this is our what dv. So our u is equal to what ln x and our v is unknown, but we know our dv, which is x. Then our du is equal to what 1 over x dx. Then our dv is what our dv is x dx. Then our v will be what x square over 2. So since we have gotten all our items that we need in order to satisfy this condition, then we can now say that our answer is what u times v. So let's pick our v first. That's x square over 2 ln x minus the antiderivative, that is the integral of what our v, and antiderivative of x square minus what 2 times du, and our du is what 1 over x dx times 1 over x dx. Now what's next? X here 1 and x here will just give us ordinary x, because once we divide x square divided by x, it will give us x. Then we can take this 1 over 2 outside, so we can now rewrite this as x square over 2 ln x minus what 1 over 2 antiderivative of what x dx. So this is equals to what x square over 2 ln x minus 1 over 2 times, let me put it in brackets, this is x square over what 2 close brackets plus c. So you can now write this as x square over 2 ln x minus x square over what 4 plus c. Our final answer for that one. Now what's next? Let's move to what? So we are done with question 4. Now let's move to question what 5. Now I will not be solving question 5 for you, because as you can see, the power difference is just 2. So you apply our integration by parts formula to question 5. So this is my assignment for you. As usual, I leave out one for you to solve so you can practice it yourself. Let's move to number 6 instead. So number 6 question says integration of what? E to the power of x sine x dx. Now, although this one too is a bit straightforward, but let's look for a way that we can solve it that will be convenient for us. So normally we have been doing u and the whole of this as dv, but let's look. If I find the derivative of this, it will still give me e to the power of x. But to find the antiderivative of this, it will give me what? Minus cos. So I can successfully say that either you make this your u, whether you make this your dv and you make this your u, you still arrive at the same thing. So using both methods or switching it in both ways will still give you the same answer. Therefore, let's just move ahead with it directly. So our u is equals to what? E to the power of x. So if this is e to the power of x, our du is equals to what? E to the power of x dx. So e to the power of x dx. Now, if this is our dv, if this is our dv, that is sine x, our v will be what? Minus cos x. Now, let me ask you a question. If we are to slot in each of this, that is, we having u times v, that's minus e to the power of x cos x, then we have to find the antiderivative of this, which will give us sine, and we solving our adding and multiplying our e to the power of x, it will eventually return us back to this. But let's try it first to see what I'm talking about. So I'll be doing that pretty quick. So we have e to the power of x. Okay, let me put this our minus outside. Cos x minus integration of what? Z, which is minus. So if this is minus x, let me just change it as plus what? Cos x times what? E to the power of x dx. Can you see? Once we are done with this, we will still have to find the what? Antiderivative of the whole of this function. So now, before that, because we are here to experiment, so there's no need to rush. Let us try the other way around by making this our u and making this our dv. So if we do it like that, let's see what will happen. So our dv is equals to what? Or let me do it like this. Our u is equals to sine x. Our du is equals to what? Cos x dx. Our dv is equals to what? E to the power of x. And our v therefore be what? E to the power of x dx. Now what did you notice? The only difference there is the what? The sign. Because if you are to find the antiderivative of this, multiplying it by what? Dv, it will still eventually give us to this. That is why I said initially that whether you make this your dv or you make this your u, you still arrive at what? The same set of answer. Therefore, let us just continue with the format in which we have been using, which is this. So this thing remain unchanged. Now let's bring this out. Let's bring this out. So that will be what? We can easily rewrite it as e to the power of x cos what? Cos x dx. Remember, I have gotten rid of the negative sign. Alright, so if this is this, then we'll be applying another integration by parts into this question in order to get our answer. So how do we do that? This is our u and this is our what? Dv. So our u is equals to e to the power of x. Our du is equals to what? E to the power of x dx. Then we know our dv is equals to what? Cos x. If our dv is equals to cos x, then what happens to our v? Is equals to what? Sine x. Because we are looking for the antiderivative of it. Now, what do we do? Remember, this is still left untouched, right? Good. We can now say that our antiderivative of this, just this portion here, is equals to what? U times v. That's e to the power of x sine x minus integral of what? Integral of what? V. And that is what? Sine x times what? Du. And du is what? E to the power of x dx. Now what did you notice? It returned us back to the initial form of this. Am I right? Can you see it is the same? So let me rewrite this. Let me rewrite this. E to the power of x sine x minus sine sorry, integral of e to the power of x sine what x dx. Now, what do we do whenever we come across a situation like this? Because it is looking as if we can't move forward and we can't move backward. So this is what you do. This and this. What is the first question? And this. Remember, your equals to sign is here. They are the same. So now we will write a very long expression. In order for me to do that, let me clean this line so that I can have a trophy of it. Are you ready? Now let's write this question. E to the power of x sine x dx is equal to what? The whole of this, that is minus e to the power of x cos x. We have written this plus the result of this, which is this, that is e to the power of x sine x minus the integration of what? E to the power of x sine x dx. So now this and this, they are the same. Then what do? We collect like terms. Since we have two equal stuff, we collect like terms. So how do? Let's write this. E to the power of x sine x dx minus because this is minus, then when it's crossing over the equation sign, it becomes what? Plus. It becomes plus. So you rewrite it. E to the power of x sine x dx is equal to what? We are now left with these two here. That is minus e. Alright. So since we collect like times, we have integral of ex power, which is the initial question. Then it is equal to what? We pick this, which we should have solved. This is it here. This is it here. Then the integration of this is the answer here. Let me put a mark for it so you can, so to avoid confusion. The whole of this here is the result of this. Now once we find the integral of this, we now have it is related to this. Can you see? They are the same. Then I collected the like terms. When I collected like terms, because they are the same, like saying a plus a. This is it over here. Then you equate it to what? This back. E to the power of what? E to the power of x cos x plus e to the power of x sine x. Now since it's like saying this is a, this is a plus a is what? 2a, right? Therefore we cannot say because we are summing up these two, we can say it is equal to what? 2 integral e to the power of x sine x dx is equal to, we cannot rewrite this, minus e to the power of x cos x plus e to the power of x sine x. Now what do we do to get our final answer? You divide everything by what? 2. So these two will cancel these two. Then our final answer is what? Then our final answer is this over. But let me write it. Therefore, e to the power of x sine x dx is equal to what? Minus e to the power of x cos x plus e to the power of x sine x over what? 2. Then you add your what? Constant. So this is your final answer for this. Thank you very much for, but before, alright, so in our subsequent video, of course I'll be creating another video on how to solve integration by parts in our next video. So this is not the end on integration by parts. I still have a whole lot more questions to give to you guys on integration by parts. So thank you very much for watching our video. Kindly like, subscribe, turn on the notification bell so you can get notified whenever we upload our next video. Thank you very much. God bless you. See you in our next class.